FRQ number 1, we are provided with the function f up above that's on the domain from negative 3.5 all the way to positive 3.5. And then we also provided with function g of x. In the first part of A, we want to find the value of h of 3 as a decimal approximation. Remember, we're going to round to the nearest thousandths. And so let's get started making sure that we're showing all of our work. So h of 3 is equal to g of f of 3. And now I'm going to come up above. I'm going to locate where x is 3 in function f. I go straight across, and the output value is 1. Okay, I'm going to make sure I show even additional work here. So I'm going to plug 1 into this function, 2.916 times 0.7 raised to the first. Remember that FRQ1 and FRQ2 are calculator-related problems. So let's take 2.916 times 0.7 raised to the first power, raised to the first power. And then this particular problem, let me come back here. It says decimal approximation, so I am going to round this to the nearest thousandth. So approximately 2.041. Let's go to the next part. Let's find all of the values for which f of x equals 1. All right, so if I come up here and I draw a line going straight across, I can see f of x equals 1 when x is equal to negative 3, x is equal to 0, and x is equal to positive 3. Let's go on to part B. In part B, we're going to find all the values of x, again, for decimal approximation, for which g of x equals 2. So I'm going to start with g of x. Let's do this a little bit neater. G of x equals 2. And then I'm going to write down this function, g of x equals 2.916 times 0.7 raised to the x power. I want to know when these intersect. So I'm going to write, using a calculator, I will identify the intersection point of the two functions. So I'm going to do that at this time. I'm going to come up to, let's do this, and do second, second plus 712. And now I'm going to go y equals, so y sub 1 is going to be my 2, and y sub 2 is going to be 2.916, 0.7 raised to the x power. Okay, got that down. Let's see where they intersect. I may even go so far to show my work so the AP reader understands how I was able to achieve this. So I want to know, where is this intersection point? Second trace, intersect. Okay, so I'm going to go first curve, enter, second curve, enter, and get as close as possible, and enter. Okay, so this is 1.057 and 2. All right, so now we need to indicate what is the x value. So x is approximately 1.057. All right, let's go on to the next part. Next, we are going to determine the end behavior of function g as x increases without bound. And I was looking over FRQ1 on previous questions. I noticed a lot of people putting it in the wrong notation. So let's talk about that. If I go up here and I graph this, it may appear like this function is intersecting the x-axis and going down, but if I extend this, we can see that this function g of x is getting closer and closer to y equals 0, but it's never actually intersecting with that x-axis or when y is equal to 0. So when we find and we identify the limit, so the limit of g of x as x increases without bound, we are either going to be going up to positive infinity, down to negative infinity, or it's going to get closer and closer like this, closer and closer to a y value without actually ever reaching it. And that's the case here. It's getting closer and closer to an output value of 0. Okay, let's go on to the third part of question. Okay, the third part wants us to determine if f has an inverse. F does not have an inverse. And then the second part is going to say, give us the reason why. So let's come up here and see. Okay, ready? F is not a one-to-one function. To be one-to-one, we want the AP reader to be able to understand, be able to acknowledge our understanding of this. So f is not a one-to-one function. To be one-to-one, you could use the word input or x value, every input value corresponds to a unique output value, and every output value corresponds to a unique input value. F does not pass the horizontal line test. And so we can see this, it does not one-to-one, does not pass horizontal line test. So 3 goes to 1. Here's an example. 3 corresponds to 1, 0 corresponds to 1, and, negative 3 corresponds to 1, and positive 3 corresponds to 1. So I think in this case I've been able to fully share why we know that f does not have an inverse function.